So I'm going to review some near-term options for continuing asteroid radar observations. I'm going to actually skip over a fair bit of what I have in these slides because you've all just heard it. The idea here is to focus on near-term things we can do in the next few years to continue radar observations. A rebuild of Arecibo, as Ann talked about, is a very large project and will take some time. So what can we do more immediately? Lance talked about what can be done with Goldstone, as did Ann. Goldstone can detect with the Goldstone Solar System radar on DSS-14 about 60% as many objects as Arecibo could, but there is a bit of a bias there. It's a lot of smaller things passing very near the Earth and fewer larger things more distant. As Lance talked about, it's been about 35 objects per year with Goldstone when the transmitter is running at full power. There are many more targets that are currently observable that aren't. Of course, again, Goldstone DSS-14 especially is primarily doing spacecraft communications. There is only so much time available. Karen talked about Green Bank, again, bistatic radar receive, or observations with Goldstone and potentially other places transmitting. The phase 1 transmitter, which you heard about, bistatic only right now. And then we saw the proposal for a much higher power system, which would take some years to build, but could potentially approach the sensitivity that Arecibo had, at least when the weather is favorable. Again, we have collaborators in Australia. I've referenced a few papers here. You all can see those up at the top right. Those are from the Australian group. They've been working with the DSS-43 antenna and then receiving with the Australia Telescope Compact Array a few hundred kilometers away, and potentially could also receive with the Parkes dish, which would be more sensitive. But again, it needs a new back-end receiver, which it doesn't currently have. I'm going to talk a bit more about the other facilities Lance mentioned. I'm going to summarize the work those teams have done and kindly provided their information to me. I apologize when I get things wrong here, if I do. I hope I don't. So the Haystack radio telescope, there is inside this large radio dome a 37-meter antenna. Transmitter is working at 95 gigahertz and 10 gigahertz. It's currently used for satellite and orbital debris monitoring by Lincoln Laboratory. This is designed for extremely high resolution imaging of things very near the Earth, because that's what you care about if you're monitoring orbital debris. And looking at satellites, resolution is as fine as 10 centimeters, which is amazing from asteroid radar standards. But again, it can only observe things passing very near the Earth within a lunar distance or two, depending on the size of the target. It observed Duende during the flyby in 2013 as a demonstration. Maybe a couple of dozen targets per year here, small mini moons, small things passing by. Again, the Haystack Observatory team provided some information to NASA a few years ago as in response to a request for information. There is quite a lot of details in that one for NASA to consider here. Presumably they would need to propose to NEOO or a similar program to do more planetary work. And they have some interest in doing that. You heard Lance mention ISCAT in Scandinavia. So this is incoherent scatter atmospheric radar studies. They have several facilities across Norway, Sweden, Finland. The 32-meter UHF and 32-meter antenna operating at UHF 930 megahertz was used by Juha Vernen and a group of collaborators to observe Duende again, because it was such a close flyby in 2013. That system is supposed to be available through maybe 2025, 2026. It's then scheduled to be decommissioned in favor of the new ISCAT 3D system, which is currently being built. You see here one of their antenna tiles. This is a large phased array. The transmitter system is to be a 70-meter equivalent aperture, just in phased array tiles laid out. This is working at 233 megahertz. The resolution here is nowhere near as good as the higher frequencies, but it does have a very wide field of view. and could observe, again, things, mostly small things, because there's small things that are passing close to the Earth. And they estimate a target rate of maybe 20 objects per year. One other facility, which Lance mentioned, which has not yet been used for asteroid work, unless I have missed something, is the Terra Radar, which is operated by the Fraunhofer Institute in Germany for ESA. There's, again, a large radio dome, 34-meter antenna. This is 16.7 gigahertz. It's only a few kilowatts average power, because that's what they need to observe stuff in Earth orbit. But again, maybe a dozen or so targets per year that could potentially be seen. So we have quite a lot of options right now in terms of facilities. Arecibo, of course, is up there for comparison and no longer available. I've indexed here the approximate range limits relative to what Goldstone can detect. The idea here is that try to get some sense of how many things each of these can observe. The DSS-13 system, we have somewhat limited range options. Only 30% is far away. If we had the same size of target under the same observing conditions, this is all very rough because you can get more time on DSS-13 than 14, for instance. Apologies, somebody is asking me a question.
Please
I'm reminded.
Ignore the question for the moment.
Okay, I'm just reminded we are, of course, finding more objects, so there will be more targets. The new DBT phase 1 transmitter is not receiving with one VLBA antenna is not quite as good as DSS-13 is, receiving with another 34-meter. If you can phase up all the VLBA antennas, that becomes a bit better. The phase 2 proposal that Karen talked about for high-power DBT transmitter with a much larger receiver. Here I've used 100 meters if that's a monostatic with DBT receiving with itself, or a large number of phased up next generation VLA antennas. It's a bit more sensitive than Arecibo. This is subject to some variations due to weather. The Australian team right now is a bit more sensitive than DSS-13. It's not as sensitive as Goldstone. They can do quite a bit better if Parkes is made available. The Haystack System, the ultra-wideband satellite imaging radar is the acronym there, working at the W-band 95 gigahertz. Again, not as sensitive as DSS-13 even, but it can catch a lot of really small things passing nearby. And if we understand correctly, there is plenty of time available. ISCAT right now, very tightly range limited, but the new phased array will push that out quite a bit further. And then the Terra system is sort of comparable to Haystack, maybe not quite as sensitive. All of these together, maybe you have 2/3 as many targets potentially observable if observing time is available, if funding to support that is available, than Arecibo could observe. But as Anne noted, that is things passing near the Earth. But we have many options available, and we can keep doing some stuff, even in the absence of a new high-power facility. And I stop and take questions here.
Thank you.
I'm going to turn off the screen sharing so I can see what's going on a bit more easily. Okay, I have a question from Dan Mazinek. Should I just read stuff off the chat here?
Yes,
okay.
Go ahead.
So Dan Mazinek asks if there are potential limitations due to international restrictions, but is fast, if possible, option for near-Earth objects observations. Those of us who are paid by NASA are still restricted from talking to Chinese government-funded researchers. The National Academies does not have that restriction. Last week, Heng Bo of the Chinese Academy of Sciences talked to the Planetary Science Decadal Survey, relating the FAST system is not yet been used for planetary radar work. There are some discussions of this. You don't have a transmitter on FAST. It's not designed to have a transmitter up in that tiny receive cabin, but you could transmit with the Chinese DSN sites outside of Kunming and Shanghai, and then bounce off the object and receive with FAST. Or you could do some, if you could negotiate the international collaboration, you could transmit from Australia and receive with FAST, but that would be a complicated political system set up there. So far it hasn't happened because the FAST dish is still not really up to performance at the higher frequencies, 7 gigahertz, 10 gigahertz. It may get good enough to be used at those high frequencies, but right now it's only good up to about 2 gigahertz, so the sensitivity is just not enough.